Okay, here we go. Section 2, Chapter 7. Your objective for this section would be explain why coal is a fossil fuel, describe how petroleum and natural gas form and how they are removed from the earth, and I will include a little bit about fracking that will not be in your notes. Summarize the process of nuclear fission and nuclear fusion. Explain how nuclear fission generates electricity. I went too low too fast. Explain how it generates electricity. A non-renewable resource is one that forms a rate which is slower than the rate it can be consumed. In other words, we're going to use it up before in our lifetime, and we're not going to be able to replace it. One of those non-renewable energy resources are fossil fuels. Usually they're the remains of organisms that lived long ago. You have oil, coal, natural gas. All those come from the ground, and they're made from plants and animals that passed away a long time ago. Much energy humans use every day comes from the burning of these hydrocarbons that make up our fossil fuels. So all that stuff we burn to make your, charge your iPod and run your PlayStation, they're all part of that. When they're burned, they break the chemical bond, releases energy and light. And that's a pretty common way, heat and light. So just like anything else that burns, you get that heat and light chemical reaction, and that's where we get our energy from. Coal is the most commonly burned fossil fuel around the world. It's formed during a process we call carbonization. Occurs in partially decomposed plants and material in a swamp, and it gets buried in the mud, and then it becomes peat. As the bacteria eats that up, it starts to release gas methane. As they mix through, it actually forms over and becomes mainly carbon. The peat actually turn into carbon. So a lot of CO2, a lot of methane get released along that process. If it remains, if conditions are not optimal, we can use peat. Peat will burn just fine. It has all that in it very, very well. Coal's a little better, but peat will work if you're looking for an energy source and you're stuck. Okay, there are different types of coal formed from different kinds of different time frames of when they do. Different stages, that's where I'm at, 4 stages. You got peat, lignite, bituminous, and anthracite. So make sure you know the difference between them. I'm sure there will be a question on that. Again, this is a picture right from your book, so it should be pretty straightforward on what it is. Alright, partially decomposed of plants remain forms, and you get that it's brownish black stuff that looks like peat. You see it in swamps and marshes. It's buried by other sediments. As pressure gets to it, it becomes lignite. It's also called brown coal. It is a great coal, burns very dirty. Alright? And what I mean by that is it gives off a lot of waste when it burns. It will burn just fine, but it has a lot of pollution to it. As the increase in temperature and pressure and compacts that lithium, it forms bituminous coal. It's made of 80% carbon. So a little cleaner burning. Anthracite, the hardest form, is produced when bituminous coal is under high temperatures and pressure, and it's made of 90% carbon. And as we go up, each one burns cleaner and cleaner. Alright, now we get that mixture of hydrocarbons. You get the petroleum and natural gas are a mixture of those hydrocarbons. Fossil fuels form when heat and pressure cause chemical changes to remain, and change the remains of those microorganisms and plants. They're a very important source of energy for transportation, farming, and many other industries. We use petroleum for oil in our cars, and I don't mean for oil. We turn it into gasoline. Natural gas is what heats your house and runs a lot of your farming equipment. We have to find permeable sedimentary rock. Permeable sedimentary rock allows gases and liquids to pass through them. That's what that means. Petroleum accumulates beneath cap rocks and fills the space to form an oil reserve. Natural gas runs above that, so when we go to get one, we usually get the other. And because it's less dense than both petroleum, natural gas will go above them because it's less dense than water and oil, so it's always on the top. And here's an oil trap. Again, you have natural gas that forms there, so we can pump that out. When it says impermeable, that means that nothing passes through that. Same thing happens in the picture on the right, although it's a shift of a fault, which traps the natural gas and the water in there, and it can't get out. Where the well is drilled into an oil reserve. They often flow to the surface. You see that in the movies where they're welling down or digging down, all of a sudden it sprays off the top of the oil rig. Oops! After the pressure is relieved, rock removes, they rise up and out through the well. So we can just form that well and then we can pump the oil out. Fossil fuels like minerals are one of the main sources of energy, but are also non-renewable. So once they're gone, they're gone. Once we use them up, we won't have them again. Crude oil, that's the petroleum they actually pump out of the ground. We use to make plastics, synthetic fibers, fabrics like nylon and what's this dress? Spandex and that kind of thing. It also makes rubber, medicines, waxes, fertilizer, shampoos, and a lot of other stuff we use. So petroleum products are not just in our cars. Coal is the most abundant fossil fuel in the world. 2/3 of the known deposits of coal occur in the United States, Russia, and China. So most of the coal comes from either one of those three places. Oil shale is also very abundant. Problem is it's real hard to get, and it costs a lot of money to get. So until the cost of oil keeps going up, it would not be worth it to mine it in most places. Before we do that, well, what is a cap rock? Again, pause your video, fill it out. Okay, good. Cap rock is a layer of impermeable rock, top of oil flow. It doesn't allow the fluids, so the fluids can't escape. Alright, before I do nuclear energy, we also need to talk about the fact that we do, that's where fracking comes in. Again, fracking is where they pump down water down into the ground, and they put it under such pressure it shatters the rock around it, releasing that oil and that natural gas we've talked about. So actually they pump down below that or into that permeable rock layer and bust it up. And when they bust it up with the water they're pumping down in there, the hydraulic water they're pumping down in there, that's when that gas are released. So it's a very cheap and easy way to do that. Again, you've seen the dangers of that. If you want to know more information, just do a search in Google on fracking and you'll find more than you ever want to know. Okay, nuclear energy. When nuclear reaction is called, it's called nuclear energy. We need to talk about the fact that all energy is basically produced the same way. We take water, we turn it into steam, it turns a turbine. Oh, that's twice. Sorry. It turns a turbine which generates electricity. Sometimes, like when you use a hydroelectric, like a river, the water itself just turns the turbine. So that's a normal process. Usually, in this case, we'll use oil. The oil will heat up. We put a boiler put a flame under a large tank of water. We boil it with oil, turn that to steam. In this case, we're not going to use oil. We're going to use a nuclear reaction. Scientists discovered the atoms had smaller fundamental parts. We could split those, and that you get a nuclear reaction when you split them. And so nuclear fission is a process when we actually split those atoms. When they split, we get extra neutrons as well as energy. And the newly released neutrons begin a chain reaction by striking nearby nuclei, so they'll hit one, which blasts off into two others, which split those, blast off into four others, and we get a chain reaction to split all those nuclei, and we get a lot more energy that way. If it was uncontrolled, it could escalate quickly and there'd be an explosion. We keep a very tight control on that reaction, and so it can produce heat, so we can generate that heat to boil water, to generate steam, to generate electricity. Okay, what causes that chain reaction? Again, pause your video, don't just write it down. As neutrons strike neighboring nuclei, the nuclei split, release additional neutrons that strike others, and you cause that chain reaction. Now, here's how it works. Nuclear reactor is equipment that made to control that nuclear fission, so when those reactions happen, it's under a controlled environment, so it doesn't explode. If we have a meltdown, that's when things get out of hand. What happened in Germany or in Japan a couple years ago when the tsunami came in and took off the power plant? That's what happened there. That reaction got so hot that it actually melted through the cement floor, and that's what a meltdown is. And we can talk more about that in class if you have questions. Currently, it's uranium-235 is the only naturally occurring element we can use for nuclear fission. It's mined and processed into fuel pellets, and these pellets are placed into rods to make fuel rods. We take these rods then and we smack them with neutrons to start a nuclear reaction. As their nuclear reaction happens, it gets real hot, and we pump water in those fuel rods, which take away the heat. That heat is then, as it gets hotter, it's pumped into the second circuit where it turns into steam. the steam is pumped through to turn turbines with power electric generators. So it's, again, same process, just a different way of doing it when we talk about the oil making electricity. Then usually that other circuit carries away the excess heat and releases that heat out into the environment. So you'll get that heat coming off out into the environment, which is a little bit of heat coming, not a big deal. So here's your picture of a fission reaction. Again, that's a picture from your book. Okay, here's the good news. There's no air pollution. So we don't burn any fossil fuels, so nuclear power is great for air. There's no air pollution at all. So it doesn't help pollute the air. Oil and coal, especially coal, pollute the air very readily. However, the waste of that water, and the water is radioactive once it comes out of the fuel rods, and the fuel rods themselves, once they're used up, what a half-life is how long it takes a substance to break down. And we're talking about stuff that takes forever to break down. And when I mean forever, I mean thousands of years. So we have to take that stuff, and a lot of times what we do is we put it in a big barrel right now, and we're shipping it out to Nevada and storing it under a mountain. And it's going to be stored there for thousands of years. As long as it never leaks, we're great. If it ever leaks, it'll cause all kinds of problems, because radioactivity obviously is not a good thing for living organisms. And destroy plants and animal cells, cause harmful change in genetic material. There's all kinds of bad things that happen when that happens. Now, fusion is the exact opposite. And fission, you're splitting. So a fissure, fission, splitting. Fusion, you're putting it together. You're fusing it together. So it's a process by which nuclei of small atoms combine to form new massive nuclei. So as you put them together and they fuse together, they release energy. All the energy that reaches Earth from the sun is produced by nuclear fusion. Our sun is a giant fusion nuclear reactor. You have hydrogen, as they slam together because of all the heat, they fuse together and form helium, and that gives off more energy, which forms more heat. Only occur at temperatures of more than 15 million degrees Celsius. So you have to have the surface of the sun to get that kind of heat. The good news is helium is the only thing that's left, and they're harmless. So if we could ever pull this off, where we didn't have to have temperatures at 15,000 or 15 million, see, the problem we have with the fusion reaction is it takes more energy to heat up the area to get to 15 million degrees Celsius than it does the energy we get back out of it. Alright, that should help. Hopefully you get some idea what you're doing. Hope you enjoyed it. Good luck.